Hi everybody, we're starting our unit on momentum. Now, I'm pretty sure that everyone has heard of the word momentum, and maybe we've heard it in, if we're watching sports and we're watching a football game and the announcer says that the player's momentum carried him out of bounds, or the player's momentum knocked the other player backwards, or if you're driving, a person's car's momentum may have caused them to skid off the street. But what is momentum? What are we actually talking about when we say momentum? Well, a couple things that we need to know. First of all, momentum is symbolized with a lowercase p. Okay, this is a lowercase p, not a capital P. We'll talk about what a capital P is later on in the year. But momentum is a lowercase p. And momentum is the measure of a motion of a body, or in other words, it is mass in motion. So in other words, anything that is moving and it has mass, it has momentum. And we can quantify momentum by comparing its mass and its velocity. So how much mass does an object have? How fast or how slow is it going? That'll give us the how much momentum that object actually has. So we can calculate momentum. Remember, momentum is lowercase p. Momentum is mass times velocity, m times v. And since we are measuring momentum, we know that mass is measured in kilograms, velocity is measured in meters per second. So if we were to multiply those two products, our unit for momentum would become kilograms times meters per second. Mass times velocity. Kilograms times meters per second. So anytime you see some variable listed to you in a problem and the units are kilograms times meters per second, it means that it multiplied the mass times the velocity and it gave you the momentum of that object. So let's look at some examples here. In example 1, it says if a car has a mass of 1,000 kilograms and is traveling at 35 meters per second, what is its momentum? Well, if I look here, it tells me that it directly has 1,000 kilograms as its mass. So this is m. It's traveling 35 meters per second, so that tells me how fast it's going. That's velocity. And it wants to know momentum, which is, we said, lowercase p. So, according to our equation, momentum is mass times velocity, or simply just m times v, mv. So, if I'm solving for momentum, I know that I'm solving for p. The mass is given to me. It says that it's 1,000 kilograms. And it is moving 35 meters per second, so the velocity is 35. So this is simple. When I multiply 1,000 times 35, I get 35,000. And remember, since I'm multiplying mass times velocity, then the units for mass are kilograms times the units for velocity are meters per second. My answer becomes 35,000 kilograms times meters per second. All right, let's look at example 2. Example 2 says a dog is running with a momentum of 5.3 kilograms times meters per second and a velocity of 1.7 meters per second. What is its mass? So it tells me it has a momentum of 5.3. And I know that's momentum not only because it says so here, but because my units are kilograms times meters per second. This is a unit for momentum. So my symbol will be p. And then it tells me it's got a velocity of 1.7. So this is v. I want to know what the mass is, so I'm solving for m. So your equation is p equals mv. Mass times velocity. So this time it gives you p, it gives you the momentum as 5.3. and I'm solving for the mass, so mass is unknown, so I'm going to rewrite it as an m, and velocity is 1.7. So if I want to get m by itself, then I need to move 1.7 to the opposite side. So to get rid of 1.7 on the right, I have to do the opposite operation, and that's to divide by 1.7. And whatever I do to one side, I have to do to the other side. So this side cancels out, and I isolate m. And 5.3 divided by 1.7 gives me 3.12. And my units for mass are still kilograms. Okay, let's look at another example here. Example 3 says a bowling ball of 35.2 kilograms generates 218 kilograms times meters per second of momentum. What is the velocity of the ball? So it's telling me that this ball has a mass of 35.2. It generates 218 kilograms times meters per second. That unit, kilograms times meters per second, measures momentum, which is a p. And I want to know what the velocity of the ball is. So I'm solving for v. So I want to give you a minute or so to try to calculate velocity on your own. You can go ahead and pause the video at this point, solve for velocity, and then press play when you're ready to find the solution. Okay, so our equation says P equals m times v. Momentum equals mass times velocity. The momentum was given to me. It was 218. The mass of the bowling ball was also given to me, and it's 35.2. I want to know the velocity, v. So, like we did up above, if I'm trying to solve for v, but it's being multiplied by a number, then I have to do the opposite operation. That's to divide by that number. And whatever I do to one side, I must do to the other. So when I do that, my 35.2's cancel out. And that allows me to have v isolated. And in my calculator, 218 divided by 35.2 gives you a velocity of 6.19 meters per second. Okay, let's look at our last example here. Example number 4 says a 20 kilogram child is riding a 5 kilogram bike with a velocity of 4 meters per second to the northwest. What is the momentum of the child and the bike? So I'm going to give you a chance to try to work on this one on your own. I will mention this. It's asking for the momentum of the child and the bike. So you've got a child with a certain piece of information and a bike with a certain piece of information. If the child is running on the bike, what does that mean in terms of momentum? I'll give you a minute to try to solve this one on your own. You can go ahead and press pause. When you're ready, you have a solution, you can press play, and then I'll share the solution with you. Alright, so what we have here is I've got a 20 kilogram child. So kilograms measures mass. And that child is riding on a 5 kilogram bike. That kilograms also measures mass. So I've got the mass of the child and the mass of the bike. And then it gives me the velocity, how fast it's going, v. I want to know the momentum, which is p. So like we've done before, p equals m times v. So I'm solving for momentum. Now it's my mass is not just a single number. Okay, my mass was the mass of the child, which is 20 kilograms, plus the mass of the bike because the child is riding the bike. So that gives me a mass of 25. So my total combined mass is 25 kilograms. So that is what I plug in here for m. And we said the bike was moving, the child and the bike are moving at 4 meters per second. So when I multiply 25 times 4, I get 100, and my units for momentum are kilograms times meters per second. So we looked at 3 examples here. We looked at an example with our momentum equation solving for m, mass. We looked at an example solving for velocity. We looked at an example solving for momentum. There's only a 3-variable equation, so you're either multiplying or dividing or a combination of the two, but that's it. P equals m times v. Okay, so use these examples. Hopefully you've written all these examples down in your packets. This is on page 2 of your packet. What I'd like you to do now is turn to page 3 of your packet and continue working some momentum problems, numbers 1 through 14. This will be a daily grade. Okay, use your notes to help you answer any of the questions that you need. You're solving for mass, momentum, and velocity. Again, that's page 3, numbers 1 through 14.